over just so we can get it from the recording. So I'm trying to work on encapsulation. From the definition of encapsulation, we said that encapsulation hides attribute of a class, all right, and a method into an object such that the object gets the attribute, all right. So um encapsulation is the concept of bundling data attributes and methods that operate on that data into a single unit object and controlling access to that data, all right, to that data attribute. Attributes are often made private and accessed through getter and setter method. All right, so come here. I said I wanted to create a bank account. I see a bank account as an object, and an account always has the attribute of account number, balance, account name. Okay, so in encapsulation, you have to make your attributes private. Okay, private, balance, what other thing, account name, account name. All right, so I've done that. Now the next thing I'm going to do is to write my constructor. How do I do that? Public account. Remember we said yesterday it has to have the same name with your class. Okay, so what am I putting inside here? I will put string account number, I will put double balance, I will put string account name. All right, let me start with string account name, string account name, account number, string account number, what other thing, double balance. Okay, all right, so what follows, this dot what, dot account name equals to what, account name, this dot account number equals to what, account number, this dot balance equals to balance. Okay, that is that for the constructor. So what is the next thing? I'm going to write a method, all right, that is different from the main method. So I have, what are the actionable points for creating an account? All right, what do you think are the actionable points? Number one, I want to get my balance. Number two, I want to withdraw. I want to deposit. I want to change my PIN. I want to what other thing? Those are actionable points. Can also call them scenarios. All right. So we have okay. Okay, so what do I have? So the first thing I want to do is to get my balance, because I have an attribute balance right there. So I will say public double. What do we say about this? This is a return type, public double. Now we talked about setters and getters. All right, we say that encapsulation is a concept that bundles your data and method, or your attributes and methods, all right, into a single unit class, and controlling access to that data by making those fields private using getter and setter method. So instead of our normal method, we do getter and setter. All right, so the first thing is we say get balance. This is our first getter, get balance. All right, get balance is already written down there for me. Okay, so I'm saying get balance. All right, so what balance am I talking about? Talk about that later. Return, just return. Return, what am I returning? Okay, I want it to show my balance, that's all. That's the first method. What other method? We said there is deposit, right? Deposit. All right, so public void deposit. So um deposit is for deposit it might require something extra. When you ask it to get your balance, it will just display it, right? But when you are depositing, it's like you are adding an extra amount to your balance um to get your balance. Am I right? So when you are depositing, it's like an arithmetic operation is being performed, right? So think about it. You want to deposit, so I'm not going to just put return. What's the name now? I'm not just going to put return balance here. I'm going to ask it to I'm going to ask it to input the amount. Not input, like I'm going to take in a parameter. All right, I'm going to take a parameter amount, and the amount is saying that the amount added to the balance to give, the amount is going to be I'm thinking the amount is going to be my balance plus the extra money I'm depositing. I think that makes sense. Okay, so meaning that I'm going to say my balance. I'm going to say my balance plus whatever I'm going to deposit will be equals to my balance. Okay, so I'm not going to put any amount there, just any amount the user enters will be. Okay, now I have public void deposit. What am I depositing? All right, it's going to take in amount. It's going to take in amount. Okay, I know you have questions, but let's finish this. Okay, so we have deposit. We can also say withdraw. So when you get your balance displayed there, you have a deposit. All right, and then you also want to withdraw. If you want to withdraw now, you're talking about you will check your balance first, and then it is if you have balance, that's when you'll be able to withdraw, right? Meaning that for you to be able to withdraw, you need to have the correct amount in your account, right? Okay, so I think this might also involve, so at this point, let's say public void withdraw 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 okay, so public void withdraw. What am I withdrawing? Okay, public void withdraw. So if the amount in my account, all right, if the amount in my account is is um is less or equal to my balance, all right, if the amount in my account is less, oh, this formula is wrong. I was wondering why I didn't. Okay, so this is what it should be. So if the amount in my account is less or equal to my balance, meaning that my balance with any other amount I added to it has to be more. So it has to be like balance uh, uh, if okay, so amount is greater here, right? So if just this scenario, amount if amount if amount is less than balance, if amount is less than balance, what should it do? If amount is less than balance, then it should I would just say print out amount, print out amount, print out amount. Okay, else okay, else 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 what now? Let me make this screen bigger. Okay. Okay, else just print out insufficient form. Dot print insufficient form. You can go ahead and do any mathematics you want to do here. So, but the story here is we have an account as an object, having attributes, account number, balance, and account name. Now we write a constructor having taking in account name, account number, and balance. Now we write actionable point, meaning scenarios. All right, we say method get balance. All right, so a method get balance is supposed to get a to display the balance for this account. Method deposit is supposed to ask the user to deposit certain amount that will be added to the balance that is already in the account, which is also going to be equal to amount. Now whatever amount this user has, all right, is what is going to withdraw. If the amount is less than balance, it should print out that amount. And if the case is that it is not up to the amount it can withdraw, then it should say insufficient funds. So that is how the flow is. Now what is encapsulation in what we have written? All right, what is encapsulation? The encapsulation here is the balance. Look at it very well. All right, so balance here is what? It has 4 usages. Let's start it. Balance here, the first one is supposed to be the attribute that was declared here. Now we also have it in our constructor. All right, look at balance in our constructor. And another place we have balance is in our method. All right, we have it in our method. In fact, it is in all the methods. All right, we have balance in all the methods. So the principle behind encapsulation is that you have to you have to operate on a single object, all right, that serve as a controller, all right, to all the methods. It serves as a controller to all the methods. All right, so but in doing that, you have to ensure that that particular attribute is made private. If it is not made private, then all these methods will not be able to access it. All right, for example, let's assume I make this public. All right, or what can I make it to ensure that Okay, this dot balance is still 4 usages, right? Okay. Let me use something else. Okay. Okay, it is still going to show this until I, okay, private. Okay, it is still going to show this until I probably make use of this action point, because I think my action points are still not in use. All right, they are still not in use. So one thing I will do now is I will write the main method and make it in use, put it into use. Okay, so where is our main method? Public okay. Okay. So my main method here. Somebody tell me, what do you think I should do next? I need to get balance. So what am I doing? Yeah. Okay. Okay, so what do you think I'll be doing here? Oh yeah, I want to do it, but I just hope someone remembers this. All right, instantiation, right?
Instantiate, yes.
Okay, so we have what? Account. Okay, account. Okay. Okay, so account equals to new account. All right, so here is asking for account name. I don't know why I'm still let me see. Why am I having error? Of course, public account. It's public account, right? It's public now. Public as account. So what was wrong there? Something was wrong. Okay. All right. So I have this dot dot account name. I said get balance, right? So I think. Oh. Okay. I need my balance. Okay. Account dot no deposit okay. I said deposit, sorry. Get balance, it should be get balance. Get balance. All right, so I want to get balance. Okay, so you see it is in use now. So what other thing I want to deposit? All right, so yeah, I think I'm going to enter amount also. ACCT dot deposit. So I'm going to enter an amount and say 500. Why is it there? I guess I can't put that there. Okay, so what other one? I think the next one should be withdraw. How about getting the account name? Okay, I didn't write the method to get account name, right? Withdraw. So what am I withdrawing? I'm withdrawing okay, I'm withdrawing that amount. Alright. Okay, so that is that for now. If I should run this, Let me run it. Let me run this. Let me execute this code. Insufficient font. Okay. It is insufficient font because what? I withdraw more than I have in my account. Okay, let me say 250,000. Okay. If you subtract 50,000, you have 250,000. That's your balance. All right. So what we have done here is that we have made use of the concept of encapsulation. All right. It's very simple. It's another name for saying bundling data. You simply just bundle your attributes, and that is all. You bundle your attributes. You made it private, and then you wrote methods for it. That is what we have. All right. Now, moving on to I'm sure we've used even this encapsulation before. So these are the things you encounter when you are dealing with classes and objects. Okay, moving on to polymorphism. Polymorphism allows objects of different classes to be treated as objects of a common superclass. Okay, so this is where the understanding of inheritance come into play. Now we say poly. The word poly means many. All right. So polymorphism allows objects of different classes to be treated as a single object, to be treated as object of what? Of a superclass. It supports method overriding. Remember I asked you to do a research on method overriding, something called method overriding and method overloading. Okay, so it supports method overriding where child classes provide their own implementations of methods defined in the parent class. So we are going to see an example. Yesterday we talked about the animal parent class. All right, so this was our parent class yesterday, and we had a child class called dog, right? So but when you are dealing with polymorphism, you have to deal with many objects. All right, so it allows objects of different classes. So okay, so name here is an object of this animal. Okay, so class here, dog here. All right, I didn't put it there. Okay, so dog here is also an object, all right, of I didn't put any attribute here. Okay, so let's assume I put string mouse, all right, and I write so many others. Okay, so I can also have something that look like it in my dog class and say string reptiles what is it, string reptiles, string birds. Okay, now we have how many objects here now? It's like we have reptile, we have birds, I have name, okay, I have mammals. Okay, so what polymorphism does is that it allows objects of these different classes. There is a class animal, there is a class dog, and they have different objects. Okay, so it allows objects of different classes to be treated as object of a common superclass. So what is our superclass here? Our superclass here is animal. Am I right? Because it's a parent class. So whatever object you have in dog, that object will be treated as part of animal. All right, even if it is up to 50 or 100 classes, it will still be treated as part of a common superclass. All right, so we're going to give an example. We're going to give an example. Okay, I'll create a new Java class and call it I should I call it polyanima. What is that? I thought I was creating a class. Okay, polyanima. Okay, so I have polyanimal. And what I want to do here is, okay, I will write a main method first. Public static void no, don't let me write this first. Okay, so I will write a method. What method should I call it? Okay, so we said animal does what? We used speak yesterday as an action point for animal. All right, so let me use crawl. All right, so I will say okay, public static void animal. Okay, animal crawl. So animal crawl. So what will happen is, okay, I mentioned reptiles in animals, right? Okay, let me call it reptiles. So I think it's only reptiles that crawls. Okay, I'll call this one mammals. So I'll come back to where's my polyanimal? Okay, so I have my polyanimal. I say animal crawl. So what will happen here is I'm going to call my main class, which is my animal. Animal is the super class, all right? I mean, this animal here is the super class, is the main class. I mean, it's the parent class that we used yesterday, all right? So I'll come here. I'll call my animal class. Okay, I'll call my animal class and call it animal class. Then I will okay, so now animal is my parent class, right? Now I said what is the one of the attributes we used yesterday? We used speak, if I recall. Speaks, right? We used speak. We used it inside dog speaks. Yeah, we use attribute speak. All right, so I will look at my main my parent class, and I will look for one of the attributes and I will call it inside my poly animal, right? So this is what I will do. I will use, I think this is the only method here. Why can't I add one more method? Let me see. Public void. What should I call this one? Crawl. Let's see. My snake crawls. Okay, so my snake crawls. So this is one of the methods that I have in my parents class. Then I'll come here in my polyanimal and I will call it and say this my small letter animal here. Okay, so animal dot cross. All right, so that's it. So what I have done here, all right, what I have done here is polymorphism. Let's continue. So I have a method this, and I will write my main method here and say public static void main string write my main method and say okay, what are the other classes you want to get involved? We have gotten parent class animal involved. All right, now we can get other subclasses involved in the main class. So um i have I have animal, parent animal equals what? Equals to animal um new animal dog. Is it dog? Let's call it dog. New animal dog. Then animal. Then I would say I think I also have a class dog. All right, so I can say dog my dog equals to dog new dog viper. Call my dog viper. Okay, viper. Okay, now I don't have any other class I want to get involved. I have animal already. I have dog. Now let's say so what is it that I want to print to the console? All right, what is it that I want to print to the console? I can say animal crawl. Okay, so under dog yesterday, I think we printed something like this. Okay, so perhaps I can make use of this too. Okay, I can say my dog dot something like this. Then I can say animal dot what else do I want to print? Okay, so go back. What do I want to print from animal? I want to print this. Okay, so I'll come here and do this. Yes, all right. Okay, so here let me just explain before we run this code, before we execute this code. We say from the definition of polymorphism, I say poly means many, right? Many classes. You are dealing with many classes. Said it allows objects of different classes to be treated as object of a common superclass. What is the common superclass in this scenario? Animal. So we have a common superclass animal. However, we are treating common superclass, all right, as we are treating the objects, all right, of these different classes as just one animal kingdom. All right, so we say it supports method overriding. It supports, where child classes provide their own implementation of methods defined in the parent class. So somehow inheritance is still related to polymorphism. while inheritance is dealing with a lot of sub child classes, all right, and just one parent class. Polymorphism is different, is dealing with many classes, does not have to be a child class. Actually, it's not a child class because we are not using extend here. Look at it, poly animal does not extend anything, so it is not a child class, so it is just a class. All right, so it's just a class that has to deal with a super class somewhere, which is our animal, all right, which is our animal class. All right, so here we let's go back. Okay, so here I dealt with a superclass animal. I called it animal, alright, and then I call one particular method from the animal superclass in code, and then here in my main method, I just did the normal usual thing, which is an instantiation. I say okay, animal, all right, and then dog, which is a different class, animal a different class, which is super class, dog which is a different class. I call them in my main. All right, so that is an example of polymorphism. You are treating different classes as a common denominator of a superclass. That okay, so let's execute this and see what we have. Okay, so Viper says Gbogbo, my snake crawls. Viper says Gbogbo. You remember this Gbogbo that we used is from where again? It's from my dog. So if you come here, you will see dog. Alright. You will see dog. This is dog, alright, which is like a child class to super class. Alright, so this is what it prints. However, the name we used is different. So when the name we use this time around is Viper. Alright. So Viper says Gbogbo. Then for this animal.crawl, if you go to animal, okay, then you see this new method I just added to it. So yeah, my snake crawls, alright. My snake crawls. So that is how we got it executed. Something that was in animal and something that was in dog got executed inside poly animal. Somebody following me? So it was, we have animal, we have dog, but it got executed inside a different class entirely. Viper says Bobo, my snake crawls. So that is an example of polymorphism. Moving on, we also have interfaces. All right, we have interfaces. Interfaces make use of the word interface. Actually, when you are creating it, you will see interface. So we have interface here. So usually when you want to create interface, you click on it and then you say what should we create as interface. So let's still be using our animal so that we don't get confused. So I will call this interface mammals. So the mammal kingdom, right, call this mammal. Okay, so I have interface mammals here. Is somebody joining? Let me see. Okay. Oh wow. Okay, so we are here at on interfaces now. My system is hanging. What is that? Okay. We are right here in interfaces. Okay, so we say you create interface directly. All right, this is it here. You see interface. You pick on it and then you give it a name. Okay, so what is an interface? Interfaces define a contract that classes must adhere to. A class can implement multiple interfaces, enabling multiple inheritance behavior. You see, this one still boils down to inheritance again. I told you already, just take note of inheritance, take note of polymorphism, take note of interfaces when you start dealing with automation. All right. So we say Interface mammals. What are the attributes of mammals? A mammal has four legs. Okay, lives on land. Okay, so we'll say string habitat, string habitat, um, string habitat. The difference is okay. The difference is each of these attributes I'm creating, I have to create them as a method. Yes, I think I have to do so. I will jump into creating method first. I guess that's the difference between it and other. So each of your attributes serves as a method. So you have different methods within a class, serving as within an interface class. Yes, within an interface class. So each attribute or object serve as a method interface. That is just the definition. So we have, let's do it again. And of course, another thing you should take note of in inheritance is that it uses the word implement. A class can implement many interfaces. So it usually uses the word implement. Alright? It uses the word implement. Whenever you write a class name, it uses the word implement. So I will leave this and come here and say public public class implement public class implements mammals. Okay. I think I have to remove this public first. Where is my error coming from? Class. Oh, sorry. Class what? Let me give it a name. Class. What's the name now? Domestic. Let me say domestic. Okay. Class domestic implements or interface. So this domestic now is serving as an interface to mammals. Alright. So we are saying that when you are creating your class, you have to use the keyword implement. So I say class domestic implements mammals. Right? Hope you know how we got interface. Interface, the moment you come to where you want to create it and you say new, instead of you just staying on class, go straight to interface, put the name there, and then you will get interface. Alright? Then you come down and what? Create your class. When you're creating your class, you use what? Implement. Okay, so what am I implementing? Okay, I said domestic implement mammals. Okay, so here I have to give an attribute to it. Attribute. Okay, the one I wanted to do the other time. Let's say string. Let's say string habitats. Then public what so before I come to constructor, so string habitat, string, what other attributes can I give it to? Habitat is then attribute someone suggest to me attribute of a mammals, of a domestic. Domestic stays in the house, right? So I can say let me just give it anything. It doesn't have to be stomach. Okay, so after this I will come and write my constructor. So I'll say public what is the class name here? Domestic. So I'll say domestic, public domestic. No, I didn't write that here. So public domestic. Do we need to? Okay, so attribute of a domestic animal. I already said it. 4 legs. So I'll say string. No, oh sorry, I already put it there. String habitat. Okay. String habitat, comma, string what? String stomach. String habitat, comma, string stomach. Okay, so string habitat, comma, string stomach. And then what is the next thing? This dot what? Habitat equals to habitat. Okay, sorry. Okay, string dot habitat equals to habitat. Yes. Then dot what again? Stomach equals to stomach. Alright, so that's our constructor. Then we move on. So what we will do next is you create methods. Now where interfaces is different is, like I said earlier, your interfaces, your methods, they are the interfaces. Your methods here are the interfaces. What that means is that your method is equivalent to your interfaces is equivalent to your methods, which are also your attributes. I will explain that as I write this method. So I will say public what are the action points? Okay. Okay. Now, so we are saying, what are your action points here? Your domestic animal, let's say for habitat, we say it lives in the house, right? Okay. So let's say house, public static, let me just say public okay, house friendly. Okay. What other methods can I have? I can have okay, eating habits, public void eating habits. Okay, so for house friendly, okay, I don't need to put anything inside. So should I just say return what return return habitat, return habitat. Okay. I'm not sure that is right. Publish string house friendly. For you to return habitat has to be string. Okay, let me put it that way. Alright. Publish string house friendly return habitat. Let me say this one should return stomach. Return stomach. Okay. Return stomach. Then so what we are bringing out of this is actually how we are going to declare the attributes at the interface level. At the interface level here, how do you declare your attributes? So come back here. I have method house friendly here, right? I have method house friendly here, and I have I'm kind of using a different example that I see, so it's kind of confusing. Okay. String house friendly. Okay. Then what other thing? String eating habit. String eating habit. String eating habit. Now see what is here. I'll click it. What is that? What is that? What is that? What is that? Go back. Okay. Automatically we have it. So can you see something that I'm seeing? All right. So this was what we wrote earlier. We said interface mammals, and then we wrote a class. We said this class domestic will implement this interface, and then we went on to write our constructor and then on to write our methods as usual. However, we decided that the method name is going to be a attribute in the interfaces, right? It's going to be not just an attribute, but it is going to carry this bracket, meaning that this is no longer an attribute, but what? An interface. So it is no longer an attribute, it is not an interface. Why? Because it carries the same method name. All right. Now we have string house friendly, we have eating habits. However, look at what we have here. All right, and look at what we have here also. Okay, this up arrow here that you're seeing is pointing towards here, and this down arrow here that you see is pointing towards each of these methods. Okay, now that is where interfaces come. That is where the concept of interface come into play. From the definition again, I will define it again just so it is clear. We say interfaces define a contract that classes must adhere to. A class can implement multiple interfaces, enabling multiple inheritance of behavior. Let me go and get another definition so that it will be clearer than what I'm currently giving you. I can't find the proper definition. Okay. So, but I hope we really understand what we've done here. I can see one implementation, two implementation. So these are our interfaces, right? So these are our implementation. Now the reason you have mammals, the Java divided into two different what's the name now? Two different section here is from what I explained just now. Now this mammals is considered as the interface. These are the interface house friendly interface, eating habits, And the domestic you see here is seen as just a normal class. So we have class domestic implement mammals. All right. So I think that is what we have there. Let me get a proper definition for interfaces. Okay. Okay, there is still one OOP that we have not touched. Let's see if I can touch it before. We still have time. Okay, which is like abstraction. I don't want to touch it before, but it looks like I might have to touch it for you to understand interface as well. Okay, so I can see a definition here. So I have an interface is a reference type, and it's a collection of abstract methods that makes it more difficult for you to understand. Okay, so just simply without using VB grammar. Okay, so this interface mammals is like it is a collection of implementable methods. Let's put it that way. It is a collection of implementable methods. Mammals here consist of house-friendly method. It also consists of eating habit method. So if you come here, you will see that it is actually a method, house-friendly method, eating habit method. However, it is found in interface part of the code. All right. So that is just a simple definition for interfaces. It will become applicable when you start making use of it. It becomes more clearer when you start making use of it. Now that is interfaces. We've talked about inheritance, we've talked about polymorphism, we've talked about encapsulation, we've talked about interfaces. I think the last is abstraction. Yes, the last of it is abstraction. Okay, so from the word abstraction, you already know that okay, just trying to look for a very good example. Okay, so I'm going to use a different example. Um, so abstraction is one of the fundamental concepts of in OOP, and of course it is a process of simplifying complex system, all right, by trying to hide them. An abstract class is a class that cannot be instantiated and is typically used as a base class for other classes. It can contain abstract methods, that is method without implementation. You know there's implementation here, all right? So this one has method with implementation. But in abstract classes, we see an abstract class is a class that cannot be instantiated. You already know the meaning of instantiation. And it's typically used as what? Did we finish this? We didn't execute this, did we? Okay, so if we want to execute this particular code now, we need to write a main method. Let me see if I can execute it before we try to create an abstract class. Okay, so I'll come here and write my main method. Okay. Okay. All right. So class domestic, right? Okay. Okay, so new domestic, taking in what Okay. 4 stomachs. What did I think? Okay, so I would say domestic dot eating habit dot house friendly. Then, so when it comes to this eating habit house friendly, instead of this I can just say system dot out dot print line. Okay. Okay, I can actually put something here and say let me see, okay, so so I can say stomach dot stomach system dot out dot print line. Okay, print line, whatever it is printing, return okay, so eating habit all right, so let me see what this thing will print out. I just hope it print out something that makes sense. All right, before we move over to abstraction, okay, I knew there would be a problem. Oh yeah, I need to add an override. What I wanted you guys to work on method override. Okay, so there is an override somewhere. Okay. Don't ask me any question about this part. I think you should do your research on this area because it might make you more confused if I start going into this area. And it's not a beginner level, so I'm going to skip it. Okay, let's see if I can run it now. House dog. House dog. Okay. House dog. House and dog. I think that's correct. So I didn't print anything out here. House dog. As for okay. So we are going to move straight to the next OOP concept, which we call abstraction. Abstraction is a way of simplifying complex systems by modeling classes based on the essential properties and behaviors relevant to the problem at hand while ignoring or hiding irrelevant details. So at the end of the day, for abstraction, irrelevant details will become hidden, and then there will be a simplification of complex implementations. So when defining an abstract class, you use the keyword abstract. So abstract class, the class name, abstract class, the class name. Then of course you make use of your extend. We came across, all right, we came across extend when we were dealing with inheritance. Here we said class dog extends animal, that is class dog inherits from animal. All right, and so when you are writing your abstract class also, there is a way you make use of extend. So you write a class, then it gets to inherit from an abstract class. It gets to extend properties from the abstract class, and then you can also do method override and so on for it. So for now, I'm just going to explain the abstract class. Let's consider let's create a class and call it I'll call it abstract class vehicle. Abstract class vehicle. Abstract class vehicle. So I created a class called what, vehicle. So but I'm going to change it to what, abstract, because I'm abstracting out the vehicle. So I have abstract class vehicle. Now after this you have to declare your abstract method. So your abstract method, just like the way you implemented interfaces, can you remember? Your method in interfaces were also your your interface attributes were also your interface methods. So that is the way it's going to be here. Your abstract attributes are going to be your abstract methods. All right, so let me say abstract okay, abstract string vehicle name. Okay, so vehicle name is what is the attribute here, which is also going to serve as the abstract method. All right, so then I will come here and say my class car, okay, extends from vehicle. I think I wrote it like this. So my abstract class extends from vehicle, and what are the attributes of a car? We say a car, let's say string color, or string color, string wheel, string wheels. Okay, now you have to write your constructor. All right, so I have car, what am I having? Implement method, make abstract class extends. Of course, no, I'm not doing that yet. Okay, so I have car. All right, I have car. You know what access modifier are. I didn't put access modifier here, so obviously it's also going to be just the name of the class. So I have car word string color, car string color. Okay, this dot color equals to color. Then after that, what is the next thing? I'll write my abstract method and say string vehicle name. Let me string vehicle name. All right, so but I think there will be an override here. Okay, so string vehicle name okay, what is that error I'm having? Okay, of course I will add a return statement. Return what now? Return color. Let me just call it whatever I want to call it. Okay, so I have this, and okay, no usages yet. Then I will go write my main method. So what you see here, what do you see here? Now this is my abstract method, which also serve as what? My abstraction here, my abstraction attribute. All right, that is my abstract method. All right, that is my abstract method. However, let's see how this thing works. I'm going to write a main method now. Public static void main. What's the time? Okay, we still have time. String. Okay, so here I have a method. Okay, I have a class. What is my class here? Car, right? Okay, so I have car. All right, I have car, call it small letter car, equals to new car. equals to new car. Car has color, right? So instead of color, I would say green. So I have car dot the method name, which is okay, which is color. All right, now this is what we have here. Then I can say, assuming we have more methods, you know what to do, right? Yeah, you know what to do. So we also have wheels here. All right, let me assume that this has this takes in wheels. Okay, wheels. Then I can come here and say this dot wheels equals to wheels, and then come, that's my constructor. Then I'll come here and say of course there's wheel, green, four wheels. Okay, so another person is okay. I think some people are dropping in. Okay, so here I can say maybe string name. Okay, string name, and come here and say Toyota. That means I'm not okay. All right, now I have, what am I having here? What is the error that is here? Implement methods. Return no. Okay. No, I'm not returning no. Vehicle name, return no. Okay. Cool. I can say okay. Return name, return okay, vehicle name. That is not right. Okay, let me just make this let me just make this what is that error again? Okay. No, don't do that. No, this is not it. Okay. There's something I'm trying to do there. However, um, however, I will leave it out. Okay. All right. What did I do? Okay. So that is it. I can then say the system dot out. I can put it here too. System dot out dot print line.
I think someone is trying to join.
Okay, someone is trying to join.
Yeah, she sent you a message that way.
Okay. Maybe our network is not stable. All right. So we have that. Let me run this again. Okay. Okay, so the most important thing in this abstract, all right, the most important thing in this abstraction part, is what you have seen. There is an implementation here, all right, called vehicle name, and at the end of the day, this is what it is. So this implementation that was done here was hidden here, like it was abstracted, but I can see an example here that looks more practical. So I'm going to try that one out. This one is a shape. Okay, so let's try that out as we call it an evening. New Java class shape. New Java class shape. Okay. So for an abstract, like I said, it's going to carry the word abstract. Okay, so we have abstract class shape. All right. Now we already know what will be here. You know this is going to be your abstract. You don't really need this per se anyway. Abstract, but just in case, abstract method. Alright, so you write your abstract method here. What are the attributes of shape? You have area, you have perimeter, you have so on. Alright, so we say abstract double. We say abstract double area. Okay, don't forget this is also going to be a method, so we now come here to come and hide the method. All right, so but first of all you write class, let's see, triangle. What's the area of a triangle again? Anyone? I can't remember. Okay, let's use circle. Okay, so we're saying
180.
area of a triangle.
Okay.
Okay.
That's the formula.
Yes.
Okay, B times height. That's it for a triangle.
Okay, half base times height. Okay, that's
Yes.
true. So but I'm using circle already. So I have circle shape and I can say double attribute of a circle. So double, you want to calculate the area, for example, you need your radius. Alright, you say double radius and you say double area. I think I've used area here, so let me just leave it. Okay, so I have area, I have radius, and also your constructor. That's the next thing. So we say circle constructor takes in parameter double radius. Okay, and then we say this dot radius equals to what? Radius. Alright, then we come to our method, which is your action point, and we say for an area we say get area of it. So double area, or public double, no, just double area equals so here I will return a formula. What is the formula of area? Or another thing I can do is I can make area to be equals to I can make area to be equals to okay, let's do it here. Area, I think this is the best place to do it. So this is what double area, right? So equals to mart dot pi inbuilt pi that's what pi r squared. So but then you can't just write pi r, so you have to call the mat inbuilt method in Java. So I have pi times radius times radius alright, such that when I come to my method here, I can say return this. I can say return that. However, I have to write. Okay. Now, what other thing? Now I have to write my main method. Yeah, and say static void main string. Okay, so what do we have? Okay, so I say my class here is what? Circle. Equals to new circle. Okay, and circle takes in radius. Alright, so I will say what value of radius should that be. Radius here is is double. So I will say 4.6 is my radius. Alright, then circle dot area what method did I write here? I've not written, okay, I've written a method area, right? Okay, so it returns this area as what? It should return it as this. Alright. Okay, so it should return my area as what? By putting 4.6 into this formula and calculating it and returning area. I think that's what you should do. That is what you should do. Okay, so okay, what am I having right now? Nothing having. Okay, that's override. Okay, how do I make it display my area? Okay, so I will say okay. Okay, so what is this? Static make circle radius. Oh, okay. Okay, so I know why it's 0.0. Okay, pi r square. Can somebody calculate it for me? If your r is 4.6 and you multiply it by pi, does it give you 0? That's why I'm sure that this is correct. Okay, so the explanation behind this is like I explained earlier, abstraction. So this is the calculation here. The real calculation has happened, all right, but as you can see, everything is covered. You can't see how the calculation was done. All you just see is abstract double area. So abstract double area is actually a result of a complex implementation. All right, it's a result of a complex implementation that you only get to see the implemented method as an abstracted attribute. All right, so I think that is how you, and then when you are defining abstract, you use the keyword abstract. All right, you use the keyword abstract. However, something seems fishy here. Okay, so double area return circle area, come here and return circle area. Let me see if I run you again. Okay, so what if I change the value, put it as 6.0? Still 0. I don't think that calculation is right though. I think something is wrong with the calculation. What if
Can you try 4.5 instead?
I'm even thinking of something. What if I okay, what if I come here What if I come here and say return the formula, please? So if I say return this formula and I say return this one safe, I don't need it anymore. Okay, if I say return this formula, okay, so if I say return this formula, I'm still going to have this. Okay, somebody said something. You said something the other time. Someone is saying something. Your question. I'm coming. I think I will have to do it again. We still have time before we close.
I was just saying we should change the value to 4.5.
Okay.
I don't know why. I don't know, maybe.
I don't think it's the value though. I think it's
value, right?
I think it's the way I wrote the code. Okay. So another thing when you are coding, remember to always, when you are stuck, look for solution online. There is a way you search. Okay, maybe when we are running all this training, I will teach us how you can search for solutions. Alright, to in case you are stuck. Somehow someone has done it before. You just need to find how they did it and replicate it. Okay. Yep, I think I know what might be wrong. So in my main class, I said my radius is what now? 6. So what else did I do? Okay. So another thing I can do here before coming out to say my circle or circle area, there is something I've omitted here. So I can say double, not here. I can say double, okay, I can say double circle area, call it circle area, and say equals to this circle dot area, equals to this one. Okay, and then since I want to print the result to the console, because that's what I want to do, then I will say system.out.println, and what am I printing? I will say the area is what? Is this circle area. Okay, sorry about that. Oh, so sorry. Tope, I didn't check my WhatsApp. I didn't know you were trying to come in. So sorry about that. Alright, so this is what we have here. Circle area. So I want to print this to the console. What do I get? Yeah, so that's what I've been trying to do. I just wanted to print the formula to the console. Now a recap on OOP for this week. I know yesterday we touched on what did we touch on yesterday? I think for loop. We closed up on for loop. we are done with for loop. We talked about control structures, if condition, if else condition, um, do and then for loop, and then we discussed objects and classes generally as OOP concepts. We then mentioned the common OOP concepts like inheritance, like mentioned inheritance, we mentioned polymorphism, we mentioned abstraction, interfaces, and I said there are some of these things that you have to take note of. The simplest of it, inheritance, then polymorphism, then interface, then encapsulation. Actually, encapsulation seems to be the simplest. Encapsulation, then inheritance, then polymorphism, then abstraction, and then interfaces. All right, so those are the concepts in OOP, and hopefully next week, which is getting to the interesting part, all this code that is boring, is selenium. So we are starting off with selenium next week. We'll be learning the concepts, the syntaxes, the methods in selenium. Then we will also delve into the model of test automation that we want to use. Here we'll be making use of TDD, that is test driven development. So we'll also consider that, and then we will talk about testng. All right, and then after talking about testng, we will do an example in class to for a web application. I mean, the following week and following week, and then when we get to week 7 and week 8, you will be doing a web project on your own. And on the last day of the last class in week 8, we'll deal with we'll write the code in class just to see where you must have made mistake and all of that, so correct that, and we'll write the code from beginning to end, and that is how the class will end. So congratulations, we are done with the basics of Java. Right. Questions, if you have questions, you can drop it on WhatsApp. I will try to answer them. Tokwa, I'm so sorry, I didn't know that you were